Hey guys, hello everyone. This is Nurul Huda and I am a verified educator at an online learning platform that is Unacademy. You can access my videos over there as well. So if you are preparing for CSIR NET, GATE or IIT JAM, any of these exams, you can access my videos over there as well. These are going to be very helpful in your preparation, right? So in order to access my videos, what you have to do, you have to download this Unacademy Learning app and you can search for my name, that is Nurul Huda, or you can go directly to my profile from the link given in the description. That's all for this. Let's continue with the video. Guys, hello everyone and welcome to the channel. So today in this video I'm going to take few questions from quantum chemistry and which were asked in your which were asked in your GATE 2018 exam, right? So I'm going to solve them out and I'm going to show you that how to approach towards this question and how to attempt them when they are asked in exam, right? So these questions were very easy, and to be very frank, like they don't require lot of your information from quantum except one or two are little different and little difficult also. So except them, others were very easy to be solved, and I'll try to solve them out and show you that how to do that. Okay, so we'll talk about the first one. So over here it says that consider the operator. There are two operators given to you. So a plus and a minus are two operators which are given to you, and they are basically sum of two different operators like position operator and linear momentum operators. And it is given to you in the question, that is x and px are your position and linear momentum operators, right? So what you have to find out is the commutation of a plus and a minus. So this is what you need to find out. So a plus a minus, that's what we have to find out. So what it will be equal to, we know that the formula for commutation is that is, we will just apply it on a wave function, that is psi. Okay, so we have just taken out a wave function psi, so we'll apply it on that. So a plus into a minus psi minus a minus into a plus psi. Okay, so first we are operating with like operator a minus on psi, and secondly we will operate like a plus on psi. Okay, so we'll just put all the values. So the value of a plus and a minus, we'll just put it all like that. So what we are going to get, so a plus is given to you in the question, that is 1 by root 2, and it's x cap plus I px, right? And yeah, and your a, like your a minus is 1 by root 2 and x cap minus I px. Okay, so that's what you are given with. And minus, you have to write down for a minus, so 1 by root 2 x minus I px cap, so it will like that, and into 1 by root 2 x plus I px cap. Okay, so this is how it is to be done. Now multiply them and open the bracket. So this 1 by root 2 will become 1 by 2 over here, and you will get x cap square. Okay, and then you are going to get minus x cap I px cap, right, plus I px cap into x cap, and then minus I square px cap square. So that's what you are going to get. Then minus sign and the other one, so other one will also like 1 by 2 will come outside, and it will be like x cap square, then minus I sorry, it will be like plus, it will be x cap I px cap, then minus I px cap x cap. What I'm doing, I'm just multiplying one with the other. Okay, so that's all, and at the end I will get minus I square px cap square. So that's what I'm going to get. I'll open the bracket and all, so I'll get 1 by 2 in the whole of the common. Okay, so it will become x cap square minus x cap I px plus I px into x cap, and minus, and this minus, like I square is minus 1, so this will make this minus plus px cap square. Okay, and then minus sign will change the sign of everything, so it will be x cap square minus x cap I px cap, minus minus will be plus, so I px cap x cap, and this minus sign will become plus because of this I square, and again it will become minus because of this minus. Okay, so it will become minus px square. So now what are the things which will be cancelled out? So this x square and this x square will be cancelled out, this px square and this px square will be cancelled out. What you are going to get is 1 by 2, and since this term is twice and this term is also twice, okay, so this is also written twice, so I can write it in this form, that is 2 times of I px x minus x cap into I px. Okay, so that's how I can write. So this 2 and this 2 can be cancelled out, and I can take I iota outside, so that will become px cap x cap minus x cap px cap. Now this is nothing but the expanded form of your commutator. Okay, so now you can write it in this form, that is it will become I, and you can write it in this form, that is x cap into px cap. Okay, so this is commutation of a linear momentum operator, sorry, position operator and linear momentum operator. So that value we all know. Okay, we all have solved this, we all know and how to solve it out, right? So I'm not going to do that in more detail, so you know the value of that. We'll just substitute that, so it will become I, and the value of this is minus I h cross. So if you put that, I've just put the value of this. Okay, so that comes to be minus I h cross, so it will become minus I square h cross. So minus I square is nothing but plus 1, or I square is minus 1, so that will make the minus sign positive. So you are just going to get h cross. So the correct option for this question should be your option number 3. So like this you can easily solve this question, or it just require a little bit knowledge of your your operators and operator algebra. That's all. So let's move on to the next question and see how to approach that, right. So we'll talk about this particular question. It's quite challenging question, and it's very nice also. So this is question number 34, and it was asked for 2 marks, right? So you have to tell that for a one dimension anharmonic oscillator is treated by a perturbation theorem or a perturbation theory. The harmonic oscillator is used, so it is used as a as an unperturbed system, and the perturbation is 1 by 6 gamma x cube. So that is the value of your perturbation. Okay, so gamma is a constant which is given to you. Using only the first order correction, you just have to use the first order correction, and the total ground state energy of the anharmonic oscillator is, so you have to tell about the total energy of the anharmonic oscillator. So basically, first of all, the values which are given to you, that is your psi naught, that is given to you this, that is psi naught is equals to alpha by pi and whole to the power 1 by 4 e to the power minus alpha x square, right? So this is your psi, and where alpha is your k mu by h cross square 1 by 2, or you can write it in this form as well, that is under root k mu by h cross square. Okay, so this is what your alpha is, right? So now first of all, we all know that according to the perturbation theorem, the for harmonic oscillator, the Hamiltonian is given by this, that is your Hamiltonian is given by for the ground state, the Hamiltonian is given by this. So we have minus h cross square by 2 mu d2 by dx square. This is nothing but your kinetic energy operator, and instead of mass I have put mu, because mu is the reduced mass, and over here also they are using reduced mass, so that's why I've just put mu over here. Okay, so mu is the reduced mass, so don't worry, it's the same as your kinetic energy operator, so it's same, right? And plus potential energy operator, so that will be like half kx square, so that is your potential energy operator, where k is a constant, that is called your force constant, and that is all, that also I'm using because that is given to you in the value of alpha over here, right? All right, so now since you are you are applying the perturbation theorem, and the perturbation is given to you, that is 1 by 6 gamma x cube, so now your harmonic oscillator will become anharmonic oscillator. So for anharmonic oscillator, okay, so what it will be, so your perturbation will be added into it, so the Hamiltonian will become this, that is h is equals to minus h cross square by 2 mu d2 by dx square plus half kx square plus 1 by 6 gamma x cube. So that's what your Hamiltonian will become, right? So now the first order perturbation, if you know, first order perturbation is nothing but this, that is given by E1, and that is written by E1, and that is given by this, that is psi, okay, psi naught star, okay, that is the complex conjugate of psi naught, like the wave function, and then your h, that is Hamiltonian, and psi naught, and d tau you can use when you are treating in the 3 dimension. Since we are in 1 dimension only, so we have to use dx. Okay, so that's what your value will be now. Yeah, so this is your energy for the first order perturbation. Now we can put the values over here. We have this psi naught we know, so psi naught star, that will be same only because there is no iota term, so that will be same, that is alpha by pi 1 by 4 e to the power minus alpha x square. Okay, so this is what your psi naught star will be, and alpha is given to you. Alpha is like under root k mu by h cross square. So we'll try to put all these things in this particular case. We'll put the value of psi naught, we'll put the value of h, that is Hamiltonian, we'll also put the value of psi, and we'll see that how it is to be solved. Okay, so just wait for it, I'll solve in the next slide. So we have got this, that is our E is equals to integration of psi star naught, then we have h, and we have psi naught dx, right? This was our value, and we have to now substitute all the values of like psi naught star and psi star, sorry, psi naught star, psi and h. Okay, so we have to just put all these values, and what we are going to get is this, that is alpha by pi whole to the power 1 by 4 and e to the power minus alpha x square, right? Then we'll put h, so h is minus h square by 2 mu d by dx square, then we have plus half kx square, then we have half gamma x square, right? So this was your h, and after that you will be also having the other term, that is your psi naught. So your psi naught is your alpha by pi whole to the power 1 by 4 e to the power minus alpha x square dx. Now what you have to do, you have to multiply this term one by one to all of them, and then you have to integrate. So basically this alpha by pi whole to the power 1 by 4, that can come outside of the integral because that's a constant, e to the power minus alpha x square, then you have minus h cross square by 2 mu d by dx square of yeah, so I'm having that term as well. So all right, so if I'll multiply, okay, so this is also a constant term, right? So this can be multiplied with this, and the power will now become 1 by 2 because it's 1 by 4, 1 by 4 two times, so it will become 1 by 2. Okay, so now it will be power 1 by 2, and I know I just have to multiply this, that is e to the power minus alpha x square. So yeah, so I just have to multiply with this plus half kx square into e to the power minus alpha x square dx, okay, and plus half gamma x square e to the power minus alpha x square dx. So a lot of calculation has been done over here, a lot of integral and a lot of calculus is being done over here, so don't worry, everything will be fine. Okay, so yeah, so we are going to get alpha by pi whole to the power 1 by 2. Okay, so that's what we are, that is the constant term. Now all right, so the next thing is what, we have to multiply each of them with, and we have to integrate all of them, right? So this term will now be like the differentiation of this, I'll just write one more step, so it will be e to the power minus, yeah, so it will be minus alpha x square, right? And it will be how much, it will be minus h cross upon 2 mu. If you differentiate this term, you are going to get, yeah, so you are going to get alpha square e to the power minus alpha x square. From where we got this, because we have to differentiate this term twice, so once you will differentiate, you will get minus alpha as the coefficient, again you differentiate, you will get plus alpha, so that will be alpha square, alpha, that will become alpha square. So that's what it is happening over here. Yeah, now the next term is, it will remain like it is. Okay, so half kx square e to the power minus alpha x square dx, and plus half gamma x square e to the power minus alpha x square dx. Okay, so this is what you are going to get. Now just multiply this term to all of these, okay, so just multiply this inside, so you are going to get alpha by pi whole to the power 1 by 2 integration of minus h cross d by 2 pi, and it will become alpha square e to the power minus 2 alpha x square, because both of them will be added, right? So minus minus will be plus, and dx plus integration of, so this is what it is happening, so integration of half kx square e to the power minus 2 alpha x square dx, and then plus half gamma, okay, so gamma x square e to the power minus alpha x square dx. Okay, so see, these integral, sorry, these are non-solvable. Okay, so these can't be solved like this. Okay, so we have to consider them equal to 0. Okay, because for the higher terms, like from 0 to infinite, we will solve it, so it will be like you will get 0 over here. Okay, so just take it as 0. Okay, so there is no other method to solve this, because integral of x square e to the power minus x square dx is non-solvable. Okay, so it can't be solved. You can use the isolate method, that is the product method, and you can try of your own. It will keep on repeating. Okay, so that's what it means. But there is one more thing, that is integral of e to the power minus x square dx, that is equals to under root pi. So that is what you can search it out on YouTube, that how it is to be solved. Okay, so on Google also you can solve, and you will get how it is to be solved. Okay, so this gives you under root pi. So this value I'm now going to put, because we have over here this term can be solved, and that will give you like under root pi by 2 alpha. Okay, because 2 alpha is the coefficient of over here. So a lot of calculation you have to do now, so I'm just leaving it over here, and what you are going to at the end, what you are going to get at the end, that's what I'm going to write. So you are going to get alpha by pi, yeah, alpha by pi, and whole to the power 1 by 2, and then you are going to get minus h cross by 2 pi, then you are going to get under root pi. All right, and yeah, so sorry, it's mu, right? So 2 mu, it's 2 mu over here, into under root pi, then by 2 alpha. Okay, so and you have alpha over here as well as a coefficient, so everything will be cancelled out, and you are going to get, so this will cancel out this under root pi will cancel out this. So basically you are going to get under root alpha square, sorry, under root alpha. Okay, so under root alpha into, yeah, so under root alpha into, yeah, so what was our alpha? Yeah, so our alpha is your k by mu h cross, so that's what our alpha is. Sorry, so you will get alpha to the power 3 by 2, you will be left out with. Okay, wait, I have done some mistake over here, so it should be like, yeah, 1 alpha to the power 1 by 2 will be left. Okay, so basically you will get alpha to the power 3 by 2 over here, and 1 alpha will be cancelled out, and over here you will get just alpha. Okay, so yeah, alpha into minus h cross by 2 mu, so this will be minus. Okay, so that minus and this minus will cancel out this and this, so they will become a plus sign. So you are going to get alpha into h cross by 2 mu. So that's what you will get. Just put the value of alpha over here. Wait, I'll just solve it once again, so just hold it on. So we just got this, that is we just got alpha into h cross square by 2 mu, right? So just put the value of alpha, that will be, yeah, so that will be under root k mu by h square. So that what your alpha was in the given question, and this is h cross square by 2 mu. So what you're going to get is this, that is you can write it in this form, that is k mu by h cross, right? Though under square, like under root and square will cancel out each other, into h cross square divided by 2 mu. This will be cancelled out, and you will get h cross, and this under root mu and mu, that will also cancel out, and the denominator you will get under root mu. And yeah, so 1 by 2 is also over there, and under root k is also there. So to be very precise, you can write it in this form, that is 1 by 2 h cross under root k by mu. So right like this you have to do the, like this you can do the solution, and this require, like, it took a lot of time for me to also to solve it out. And in the exam also, if these kind of question are given to you, you have to solve it in this way, and then only you are going to get 2 marks. Okay, so this is how quantum mechanics works. This is how a lot of differential and integral works, right? So that's all. So this was for this question. Okay, so now let's talk about the next question. We just have 1 or 2 left. We'll just quickly finish them out. Right, so we'll talk about this particular question. It was asked for 1 marks. Okay, and yeah, so this question was asked for 1 marks, and it's very simple. And if you try to do this question in the usual way, that is by using the, like, if you try to do it by using the usual way, this question might seem to be very difficult and it will take a lot of effort of you, okay? And it's a really pain to solve such a long like such a long calculus method. So what I'm going to do is I'm going to tell you a shortcut method to solve this particular question, okay? So the question is about like you are given with a spherical harmonic oscillator function, sorry, spherical harmonic function that is given by y, lm, and that is theta phi, with appropriate values of l and m, is an eigen function of this term, that is lx square plus ly square. So this is what it is given to you. What they are asking is that what is the eigen value. So you are given with the eigen function, you need to find out the eigenvalue. So you need to know just the basic formula of your quantum mechanics. So we know that the angular momentum is given by this, that is L is equals to Lx plus Ly plus Lz. This is what we have. And also L square is equals to Lx square plus Ly square plus Lz square. This is the equation which we all are well, like which we all know about it, right? And this equation is also used while solving hydrogen atom problem. So let this to be the equation number 1, okay? Now we also know that this L is equals to under root L plus 1 H cross, okay? So this particular equation, that is equation number 2, this equation we came across when we were solving about our molecular spectroscopy. There, while the derivation of rotational spectrum, we have used this particular relation, right? So L is equals to under root L plus 1 H cross. So this is the second equation. And one more equation, that is for Lz. So Lz is your MH cross. So this is your equation number 3. This value of Lz we have used during our solution of ESR spectroscopy. So Lz is along your Z direction, and M is the magnetization, and H cross, okay? So this is how these three relations are, and we will use these three relations in order to solve our like desired thing, right? So if I put the values in equation 1 from equation 2 and 3, so on the left hand side of equation 1 I will get L plus 1 and H cross square. Why? Because I have just squared this to this side, right? And Lx square and Ly square I need to find out, so I'll just put it like that only. Lz square, I'll just put the value of Lz in the form of a squared one, so M square H cross square. Now I can take this term to the other side of equation, so this will be like Lx square plus Ly square is equals to L plus 1 H cross minus M square H cross square. So what I have to do now, I have to take H cross as a common. So what I'm going to get is L plus 1 minus M square, right? So that's what I'm going to get, and this is the correct answer. So option number A becomes your correct choice. So like this, you don't have to do much, you don't have to solve much. If you want to solve it like in a usual way, you can take out Lx value, Ly square, Ly value, you can put it in that. Then you can take out the value of y, lm, theta and phi, the usual form of that, standard value of that, and put it over there to find out the eigen function, like to solve it out and to find out the eigenfunction, and the term which will be with the product of that eigenfunction, that will be your eigenvalue. So by that also you can do, but that will take a lot of effort of you, and that will take a lot of time also. So this is the easier way to solve this question out, and I hope you guys will like this solution, okay? So we'll talk about the next question now. So this question was again for 2 marks, and it was a pretty easy question. It says that at temperature T, the canonical partition function of a harmonic oscillator with fundamental frequency mu, sorry, it's nu, okay, it's given by this, that is Q vibrational, and T is representing at that particular temperature, e to the power minus h nu by 2 kBt 1 and divided by 1 minus e to the power minus h nu by kBt, okay, where h nu by kBt is equals to 3. So that's what it is given to you in the question, right? Now what they are asking is to find out the probability of finding the harmonic oscillator in its ground state or ground vibrational state, right? So the probability is given by this formula, that is your Nj divided by N. Nj is the number of particle in that particular level, and N is the particle, like the whole particle, okay, total number of particles. So it will be given by this, that is e to the power minus ej by kt divided by q vibrational, okay? So this is what you are going to get. Now for the ground state, we know that for ground state the energy of a vibrational, for a vibrational, like for a harmonic oscillator, the ground state energy is given by this, that is half h nu, right? So we can put it over here like that. So in the place of ej we can put that thing, okay? So half h nu we can put. So probability p can be given by this, that is e to the power minus half h nu by kt divided by q vibrational is given to you in the question, right? So that is e to the power minus h nu by 2 kt or kbt. I'm just writing kt, okay? And the thing which is in the denominator, that will come to the upside, so I can write it in that form also. So it will be like 1 minus e to the power minus h nu by kt, okay? So I haven't done much, just the thing which should be written over here in the denominator, I have taken it upside, okay? So that's what it is. So once you will solve it, everything, what you are going to get is this. So this thing will be cancelled out, yeah. So basically, okay, so this thing, this basically this thing and the thing which you are getting over here, these things are same only. So you are just going to get this, that is 1 minus e to the power minus h nu by kt. So just put the value of this, that is h nu by kt, that is 3. I'll just put 3 over here, so it's 1 minus e to the power 3. Now use your calculator, sorry, it should be minus 3, right? So it should be minus 3. Now just use your calculator, your scientific calculator, to get the value of e to the power minus 3 and put it in and subtract it from 1. So you are going to get 0.95. So this is what the answer is. So probability for this particular question will be 0.95. So like this you have to do this particular question. Let's take the last question for this particular video and see how to do that. Right, so this was the easiest of all, and I don't know why they asked this question for 2 marks. It's super easy, okay? It's super easy question, and we'll see that how to solve this particular one. So it says that for a molecule xy, there is a diatomic molecule, and we have, let psi x and psi y denote normalized atomic orbitals of x and y respectively. The normalized molecular orbital for xy is given by this, that is given by this, that is psi plus, okay? So it's given by this, that is psi plus is equals to 0.56, and psi x plus psi y. So that's what it is given to you. Now what they are asking is the value of overlap integral. So it's very easy, it's really very easy to solve this question, okay? So how to do this? See, yeah, so the how you have to do, first of all you have to resolve this equation. You have to write it in this form, that is psi plus will be 0.56 psi x plus 0.56 psi y, okay? So this is how you have to write. Now remember one thing, that if you have a molecular orbital in this form, that is psi is equals to, like molecular orbital wave function in this form, that is psi is equals to c1 psi 1 plus c2 psi 2, and then there is a condition for overlap, and that condition is given by this, that is your c1 square plus c2 square plus 2 c1 c2 s is equals to 1, where s is your the value which you are asking, the overlap integral, okay? So that's what it is. So you can do this question using this thing only. So how to do this? Just try to do this out. So what you are going to get is this, yeah. So what you are going to get is this, okay? So just put all the values. So it will be like c1, that is 0.56 square plus 0.56 square, right? And plus 2 into 0.56 into 0.56 and into s, and that will be equal to 1. So how much s will be? S will be like 1 minus 2 times of 0.56 square and divided by 2 times of 0.56 square, okay? So just solve it out, use your calculator, try to solve it, and when you will solve you will get 0.59. So this is the answer. So like this you can easily score. How much question I have taken? I have taken 4 questions, and 3 of them were of 2 marks, and 1 of them was for 1 mark. So overall you can easily get 7 marks, okay? So 7 to 8 marks you can easily score from quantum mechanics. These were the questions which were asked from quantum mechanics in your GATE 2018 exam. I hope you guys like this video. If you like this video, give it a like, and if you are new to this channel, subscribe to this channel, share it with your friends, and all the best for the exam. And if you have any doubt, if you have any query, if you want to ask any question, you can ask me out in the comment section. And that's all for this video. Thank you guys, have a great day, bye bye, take care.